Good morning, everyone.
Good morning.
Uh, Today we're going to be continuing on some of the issues in weatherization when we're actually doing the work. I wanted to start off with some air sealing and insulation situations that I've experienced in real life. A lot of the stuff is going to be referencing balloon frame construction the most because that's where we have some of our biggest challenges in weatherizing a home, but also you can have extraordinary rewards. You can do 60% energy savings or more if you do a great job on a balloon frame house. Critical framing junctures, we have them all over on balloon frame homes. It's if you look downward on a balloon frame home and you took the roof off, we'd kind of be looking down on it'd look like a piece of Swiss cheese. There's more hole than there is substance on a balloon frame house in many respects. So hitting all of these is really important. As you all probably know, if we just miss about 5%, we leave a 5% void, for example, then our effectiveness of insulation and energy savings is going to drop by maybe 20%. So it's critical to get it all. So I have compiled some slides here to talk about some of these issues. Knee walls, everybody's favorite, right? Let's go over this in different parts. And this is just a slide I picked up from a different type of work, not necessarily weatherization, but we have different issues in knee walls. And I'll use the pointer here. The upper attic that we have in here, it shows a gable vent. Now, if we have a large upper attic, you may need to vent that. But if it's smaller, you can just pack that thing full and not have any venting. Going down the left side here, this is more typical of what we do, except they're showing an air gap. And what we like to do now is dense pack this slope. And then, especially in conjunction with dense pack in the upper attic. Down the knee wall itself, and we have a critical framing juncture where that knee wall meets the floor and then out to the floor and to the wall. So we have a number of different points. This is the typical way. Now, if we insulate down the knee wall and on the floor, we have an uninsulated area that's called for becoming vented. So if we miss out on some of the air sealing, we can actually expand on any air leakage with the stack effect by creating a hole. So it gets really, really important to do a perfect job there, or as near to perfect as humans can be. The knee wall doors, as we all know, that's really a pretty heavy duty task doing that, right? Insulating the door and weather stripping it, so forth. What I've come around to advocating later on in my career after crawling around in too many knee walls was actually bringing that knee wall area inside the conditioned area, insulating down the whole side here. So we eliminate having to worry about the air leakage site here and where this could leak up through here. We're bringing it all, that space in between, bringing it all inside. The people can use it a little easier for storage, and we don't have to worry about insulating knee wall accesses and so forth. We don't have to vent out here. So the way I've done this, and I think we'll show this in the future, is I put up something like Tyvek or belly paper or something, and fastened it in place with perforated tape, plumber's tape, so that it would hold. Now, I can't get quite 3.5 pounds in there without blowing it off, but we can get it pretty dense in there and then dense pack up into that side. So that's an option, and that is a perfectly legitimate way to do knee walls. There's just more knee wall, and I talk about them a lot because it's so easy to do a knee wall incompletely. We have to hit all these framing junctures just right, or else we're going to have air leakage in there and not get the result that we'd like. Once again, and this is just showing another detail of bringing that inside. So it's something, if you haven't tried, I'd urge you to maybe think about doing some knee walls that way. It's actually, I think, a time saver and probably a money saver too, because you lower labor costs, so forth. Okay, dormers. I have some, this is a stock picture, one being built, as you can see, but using the poor man's infrared, AKA snow on the roof, I see a lot of times I'm driving by a house and I'll see a dormer, snow on the roof, and then all around the dormer is a melting area. And it's simply because, once again, people have some problems where this wall of the dormer meets the roof and so forth. We got to do good air sealing and dense packing. We got to insulate up here. So it's another challenge. My preference for insulating a dormer is to do it from the interior. I would I'd much rather do that than get way up on a scaffolding or whatever and try to work around there. But it's just from the evidence that I see, sometimes, and it's not just weatherization, it's new construction. It's just a point where people seem to have a little problem. Okay, balloon framing. I think most everyone's familiar with it, but this is a side view of what it looks like. And what we have here, they call the ribbon or rib band ledger board. These joists here are what's going to support the second floor. Balloon framing, they build the entire skeleton and then they fill it in. One of the areas of possible problem is that when we're tubing up here, we have this big void between these floor cavities, and sometimes we don't get a dense pack right in this area here. And I actually had photos of where, after weatherization, could see some mildew growing in a band across these walls here, where this was a colder surface than the other parts of the wall. So there's different ways that you can deal with this, you realize. And it just, sometimes you can just pack back in here a foot or two. Sometimes there's people that have actually stuck a bag and drilled a hole right there, stuck a bag through there and blowing it full of insulation. But it just requires a little bit of attention when you're at that juncture point. You've got that cavity there. So, as I say, it just takes a little time. And in general, it's important to note that when you've got a balloon frame house and you do your math, how much it's going to take for sidewalls, say it's going to take you 80 bags, it's not unreasonable to think that you could have a few maybe up to 5 bags that are going to go into other areas as your dense packing. That's just kind of the cost of doing business when it comes down to it. Another thing I didn't talk about in a slide, but one of these critical junctures is pocket doors. They're kind of interesting. You pull a pocket door beyond and look up into there, and you can have openings and bypasses that go all over the place. With pocket doors on a balloon frame home, or actually a platform also, if you happen to have them, there's a couple different strategies that you can use. One that I've actually run into, the pocket doors on an old house were broken. They were just stuck back in there. Well, in that case, you're in luck. You could use something and frame over the hole where the pocket doors came out. I'd back caulk, put that in, and then you can just proceed to blow an insulation. You're going to blow some back in there. But if the pocket doors operate and the people living there want them, which they're most likely to do, you're going to have to do something to prepare before you insulate. One of the things you can do, and you may have to remove a stop, is one side at a time, pull the door all the way past the opening to the other side, and then with the broom handle or something, shove some back fiberglass way back into that opening. Obviously, further than the door will go back, and then you're putting up a barrier so that when you're blowing your walls, your cellulose will stay back there, dense pack, and won't come into the area that you don't want it to come into. You may have to do the same thing on the top of where the pocket door opening is too. And it's going to depend, because there's a few different ways that those are set up. Here's just another picture of between the floors, and it's just kind of illustrating that you want to do something to ensure that you maintain a dense pack in that area. This is just a generic picture, a house with some insulation voids. This is what you're going to see in cases. I was looking for one out of my old files where I had the horizontal line between the floors, and of course I couldn't find what I was looking for, but it's out there. Now this particular house here, we have, whatever was done there, we had uneven insulation, or we got colder spots, and we end up having mildew or mold forming on those areas. We don't want to see that. Again, here I got one. I found kind of a conglomerate picture. The left-hand picture is the great, this is the poor man's infrared here. How much insulation do you think there is in that attic? If there is any, it was a waste of time and money, obviously. There's either a lot of bypasses, no insulation, or a combination of both. Interestingly, the small addition on the left side seems to be better insulated because there is snow there. A infrared picture. We see cantilever. This is another place. I mean, the best thing to do with these, dense pack them. And there's a problem, must have been up here where we didn't get full insulation in this home. This one here, it's not quite as apparent, but we have less of a snow cover over part of this, so that we're not having a fully effective insulation job. Remember, inside that attic, you want it to be pretty much the outside temperature. That roof is on there to protect the attic from moisture. That's all it's there for, pretty much. Stairways on the exterior walls. Balloon framing, and that's where you're going to find a lot of them. Those stairways are going to be totally interconnected with the framing. Depending on what you want to do with that house, I know Dave and Cole talked, I think, last week about some of the strategies of insulating these stairways. It's just a matter of coming up with a strategy. But the other thing is, need to make sure that cellulose isn't going to go where you don't want it to go. And here's an example of what I'm talking about. You've probably all seen closets under the stairways. I have not seen one in a home we were working on that looked as nice as this one. But my advice to you, if you haven't worked on a whole lot of homes like this, is that totally empty that closet out before you begin work. Because I'm pretty much going to guarantee you there's going to be some places in there where cellulose could come in. You don't want to find out after you've covered somebody's clothing or filled the closet halfway up with cellulose. That's a time-consuming thing, and also your customers probably not going to be as impressed as you'd like them to be. Same thing in balloon frame houses. Older homes, we don't see the number of closets that there are in modern homes. People didn't have all the stuff that they do now, I guess. But again, those closets may not have been finished out as well as the inside of the house. There may be some gaps in the plaster or framing where cellulose could come in there. So you want to look in those closets. You may want to empty them out. Take a look, and if it looks like there's a chance of cellulose coming in there, empty them out pretty much before you start, because it's better than what's going to happen afterward. Ceiling height changes. Some of these balloon frame homes, maybe what they call the parlor or some of the main areas, they might have a 10-foot ceiling. I'm not sure what the reasons were. Some people have said that in the warm weather, the hot air would go up, and with your double hung windows open at the top, you could dissipate some of the heat, something like that. I don't know. But at any rate, the other rooms in the house might be 8-foot ceilings. Well, you have to remember that that vertical area around where the ceiling height changes from 8 to 10 has to be insulated to the same level and sealed where they meet, where that wall cavity is, and so forth. So we don't have a lot heat loss through there. Oh, okay. Well, I wonder if I should be further away. Closer. Okay. I know yesterday when I was talking, it was better. Okay, thanks. Shed roof addition. You have an addition on the house, or you may have a shed porch roof. Normally, inside there's no sheathing on those. Now, if it's a small porch roof, for example, you could dense pack the whole thing if there's no potential hazards, you don't have lights up in there, or it looks like the ceiling would hold it. Otherwise, you're actually going to have to access that area and excuse me, do something so that you can insulate that wall area, or you're going to have a big problem. I've done this. It's never been one of my favorite things, even when I was a younger guy. Making an access up into one of these areas and putting up Tyvek belly board or something, and then again getting it secured so we could blow insulation. Once again, you may not be able to get 3.5 pounds per cubic foot in that area because it's not going to be as strong as if you're blowing against siding or something, but get it pretty close. And then when you're above there, you want to make sure that you're getting your 3.5 feet. And that's pretty much what you got to do. So you may have to take into consideration that there's going to have to be time for someone to get into that area. If it's a large shed roof that's on there, and that could be, I had an old house that I lived in that was built in the early 1800s. It was in town when we got it, but when they built it, it was farmland. There was no bathroom. So once indoor plumbing came into vogue, they built a bathroom on it, had a shed roof on there. I got in there and sealed up that vertical area. Here's an example of what I'm talking about, and it's this area up above the ceiling in here. So that vertical area right there, that's going to be just a bare stud wall for that area, siding up above, and of course your finished wall down here. But if you don't deal with that, you're going to have problems. That's a nice looking one. I told Dave that looks like after we had a housing rehab done on that house. Okay, what I've been talking about with all this pretty much is sidewall tubing. It's a great thing. I'm one of the few around, I think Jim Hall too. Before we started the tubing method of insulating sidewalls, we weren't nearly as successful as we were. We couldn't get a dense pack using it, the old method. But sidewall tubing is not a one size fits all. You need to have different types of tubes. Now, a couple days ago, we had what at least felt like one of the coldest days of the winter. It was only in the 40s most of the day. You needed a winter grade tube. And that tube, because it was cold, it was pretty stiff when it was cold outside. But then you get up to what I'd say, what we're hoping for today, like up in the mid 60s and into the 70-degree range, a mid-range tube. And it's a little different density. It'd actually be too stiff to use in the very coldest weather. But then when you get up into midsummer, 85, 90, 95 degrees, they actually make a reinforced tube to use when you're in that really hot weather. The other tube, even the spring fall grade tube, when it gets up to 85, that thing's going to be like a limp noodle when you're trying to get it up in those wall cavities. In addition, in addition, you want to have a selection of different types of tubes. Some of these things I was talking about, these dormers, they may be small areas. You don't need to have the big tube like we're using. You can get a 1-inch tube and taper down and drill a small hole where you're just insulating the areas above a window, for example, or above a door, or in small confined areas and different lengths of tubes. So one tube is not going to fit all. We had tubes from about 6 feet in length up to, I think, about 14 feet, where we could do a balloon, 2-story balloon frame house when there were no fire stops, do the whole wall with one tube. I'd rather do that than get up on a ladder, do it twice. And if you are doing it from 2 different areas, you run the risk of having a point in the middle where you're not going to have an excellent dense pack. So anybody have any questions on some of here? Back in the flames.
Yeah. All right. The rest of this afternoon, or the rest of this session, is going to be primarily videos of some hands-on training. I know I don't hit every single thing. If there's something in these videos that you want to talk about that I don't necessarily mention, throw it in chat. I'm not going to look at it while the thing's going on, but we can definitely, I'm recording this, so we'll have it, and it might make some good future videos. Unfortunately, Cole has not been here this week. Had some things going on, personal things. So GH helped me videotape this week. So if things seems a little bit different, it's because it was. But we tried to touch on some things that you guys come across in real life situations. And mind you, we're using the prop house here. This isn't an actual working home. So it's made for demonstrations like this. So bear with us. Didn't really have time to do any kind of editing on the videos. So, you know, there's a few mess ups or whatnot on it. Might get some comic relief out of it. I'm not sure, but I'm certain that you'll get something out of it. It's pretty informative, I believe. And like I say, we're getting better at this. And if there's anything that you want to see us do, now weatherization wise, it's got to be about something that we do every day. Maybe we can make a video of it and show you guys how to do it. This is kind of cool, really. It's tasking. It takes, like I say, it takes 3 days to get. I don't even know if we have 2 hours worth of material here today, but we got as much as what we have. But it just takes time. And I'll shut up and I'll let you guys watch the video. We're here at the Ohio Weatherization Training Center, and again, I'm Dave, GH, my cameraman. We're actually going to do some hands-on demonstration videos for you. I just wanted to let you folks know that I'm not wearing a protective mask and such because I'm talking to the camera. So when I'm doing these demonstrations, you in the field would be wearing all of your PPE, but for this demonstration and making videos particularly, that is the reason why I'm not wearing a mask when I'm up in the attic and such, so I can talk to the camera.
You're going.
Okay, today we're going to talk a little bit about attic prep. Some things you need to take care of in the attic before you start insulating. We went over attic ventilation. We did the calculations for trying to figure out how much insulation you're going to need to insulate the attic properly. And we've also went over the formula for a proper dense pack. Now there's a few things up in the attic that we're going to have to deal with. And we're at the prop house today, so this isn't an actual working home, but we do testing in here. But it's sufficient for, again, for what we're going to demonstrate. So right here we got typically what you folks would normally come into, a partially insulated attic that looks like a complete mess. I've put up a few props in here, but we got a junction box that needs a cover on it that it is not flagged. We have a can light here. We don't know if it's IC rated or non-IC rated. And if you look, if it's a non-IC rated can light, this is what you folks are coming up to. Insulation all the way around this particular can light. That could be a potential fire hazard. Them can lights, they create a lot of heat. And if you got that cellulose all up around there, that is potential for a fire. Looks like we got some wires over here. There's absolutely no flags in here to tell me where these junction boxes are, where all the electrical connections. We have water lines running up into the attic that needs insulated. We have heat runs that are in the attic in an unconditioned space. A few weeks ago we did a demonstration on how you could test ductwork to see if it's leaking, to see if you need to do some air sealing, but all ducts running in unconditioned space need insulated. If we move further on in here, if you can look back in here, we have cellulose insulation going back clear into the soffit, blocking any kind of low venting that we may have, if there is any in there. On this particular demonstration, we're going to show you how to address the can lights. We're going to show you how to address the open junction boxes and flagging. We're going to show you how to install soffit baffles and to keep that soffit from filling up with cellulose insulation as you're blowing it into your attic. We're basically going to prep this attic so we can blow insulation. There's another special feature for this prop house. I like to use it right here. This is simulating a floored attic. Normally, when you got all your prep done and you insulated, there would be a knee wall right here. And this could perhaps be a floored attic. You would want to come in here, and if Jim can bring the camera down, we have some air sealing going on this side. Right here. This is sealed. It just has to be able to support the weight of the insulation. We're not going to do it for this demonstration, but you would normally bore you a hole in this floor system right here and dense pack this whole cavity. Now, you would have to air seal right here as well. I'm going to demonstrate on a wall cavity in this particular session to show you how to air seal and do good and effective insulation. Okay, going on further with our attic prep, I'm going to try to install this baffle down in this soffit cavity right here, or this roof cavity right here, and pull some of that insulation out of that soffit so I can possibly put some low venting in this. So I want to show you basically how to install this baffle, but I can't get back there, and this is the real life situation. So what I'm going to do, I'm going to remove this ductwork that's going through the uninsulated area. You're not allowed, us HWAP folks aren't allowed in using that foil tape anyhow. It needs to be mastic, so this isn't a proper install. So what I'm going to do, I'm going to take this pipe out, and that will allow me to be able to get back there, rake that insulation back, and install this soffit baffle to eliminate this cellulose filling up the soffit. So what I want to do, and I already have, is I've cut this foil tape all the way around. I'm looking for some screws. I've got another screw right here. And this is where being the little guy isn't necessarily the best thing in the world, because you'll probably be called upon to do this more often. Get that tape off from around that. This is kind of cool. It's being a pain in the butt in an awkward place, because that's what you guys are going to be dealing with.
Layers or something.
Oh, let's see if I can just do that. Easy solution to a pain in the butt problem. So let me see if I got all the screws out all the way around. Feels like I do. So now I'm going to go to the other end. Rearrange my boards so I can get down here. And again, cut around, get rid of that tape. Tell you what, I may actually just take this elbow clear off. It will not hurt a thing. And we're just going to move this out of the way. Okay, you can stop.
Okay.
All right, got my heat run disconnected. I saved you guys the agony of watching me swim through cellulose and drag it out of the soffit area right here. But I'm doing this to show you folks how to install this here baffle. I like the cardboard baffles. GH is probably going to touch a little bit on how he used to do it with some fiberglass insulation. But I always like keeping some spare cardboard around because you never know when you might need it. This part of this baffle tilts down, these sides fold in, and this actually gives you your spacing that you need between this and your substrate on your roof, and that allows that airflow to come from your soffit and flow up and go out your ridge vent or your gable louvers, whichever way that you're going to be doing it. This is simulating a knee wall to some degree. So yeah, let's go ahead and see if we can install this baffle. If GH can hand me the camera, I'll show you what I cleaned out here at the soffit. All right, now right down in here, as you can see, we have our soffit vent, our wooden soffit. This is going to allow this to have airflow to come up. I don't know if you can see it, but there's already been a little bit of air sealing going on this exterior wall. Tight corners in here, of course you HWAP folks know about all that. But let's see if we can get this soffit baffle installed. Simply want to take your stapler, come down here and staple. Bring this portion down. And that's what I was saying about this spare cardboard. I got a little bit more space than I need to make my dam, excuse me, down here for this insulation. So what I'm going to do, I got that there. Just going to come here. And that should be sufficient. You may want to put wings on the side to secure it to your ceiling joist. But basically, what I have done, if I can see the camera, get a closer view of this. Mind you, all the shaking. But I've literally dammed this to keep it, my cellulose, from blowing out into my soffit. And I have more than enough airflow down through the top to eliminate any kind of moisture issue that may happen for any kind of heat loss or just moisture. We've all been in this is slate roofing. We've all been in a knee wall when there's slate roof on a house, and in the winter time this is all frosty, every bit of it. So this will allow the air to come flowing up through here. As to when that frost starts to melt, that air will dry it off. Now, to address the can light up in the attic, I'm taking the easy way out instead of messing with that one over there that already has insulation all the way around it. Thanks to my buddy GH here, the camera guy. But this is a non-IC rated can light. It says right here on the top of this label that insulation has to at least be 3 inches or better away from it, and that's because of the heat. Like I was saying earlier, these can lights create a whole lot of heat. Fortunately, like I say, we come over here to where there's no insulation, so I'm not swimming through it. You might be actually swimming through it. But I'm going to show you how to just simply put this Insulite cardboard cover over top of it. This actually gives you the clearance. You do not want to cover this with insulation. If you notice, it has vent holes in here for a reason. That's to let that heat dissipate off of this, to leave it without being so congested. But there's a problem with just setting this thing down on here. These can lights are secured by these little metal brackets that are nailed to the ceiling joist. If you're anything like me, you're kind of particular and you like things to fit exactly the way that they're supposed to fit, so you're not creating issues later on down the line by shortcutting things. I know you're most surely not going to have an ink pen. I got my trusty razor knife here. I'm just simply going to make a mark on the side of the box here where I see that bracket, and then this bracket's right on the crease, and I'm going to do the same thing on the other side, because chances are you're not going to have a pen, and I'm lacking about 1.25 inches, meaning all the way down to the floor. So I'm going to come here, right here's my mark, and come up about 1.25 inches. And like I said, you kind of want to cut away from yourself. Don't be afraid to make a notch. And then this one was right on the crease. This is always real fun when it's 100 and some degrees up in the attic. But the cool thing is, it don't have to be beautiful. It's just gotta work. Let's see where we're at with this. By luck, I got that bad boy to set down there the first time, and you're simply going to staple this. Now, this will probably be drywall or plaster and lath. You may actually have to fasten something on the side of this to nail it to the 2x member. We're fortunate here in the prop house that we can actually staple right down through the top. But you want to make sure that you get it all the way around, because you may not be the one blowing this ceiling, and you don't want Jim Bob up in there blowing that bad boy around and beating it with a hose. But if you can tell, that's on that can light pretty good. A hose isn't going to knock that off. The cellulose blowing up against it isn't going to knock it off, because you get 100 degrees up in the attic. I mean, it's probably only 65 degrees in this warehouse, and I'm up in here and I'm already sweating. And you folks know how hot it gets up in the attic. So do this and do it effectively. Do it the right way, to where somebody isn't coming right behind you and having to redo it. But you just seen me cover a can light. We should have the proper clearance all the way around, able to insulate this ceiling cavity right here. Okay. The next thing that we're going to need to address in this particular attic, we put our soffit baffle in. We've addressed the can light, of course, over there where there was no insulation, trying to make it a little easier on this fellow right here. But now we've come to junction boxes and such. This particular junction box, when I walked up here, did not have a cover on it. You need an approved cover for a junction box. It just cannot be any chunk of metal. Say you got some sheet metal or something and you drill a few holes in it and slap it on there. That's not going to work. An approved cover is made or designed to be able to support your weight. Say this junction box here was down below all this cellulose. and you're crawling through here and you put your knee on that, and if it was not a necessarily approved cover, your knee could crush this. If there was a bad connection in there, touch the bottom side of this, you might be sporting a new hairdo. So basically we want to find the cover that goes on here, an approved cover, put it on. There. Now we've secured the junction box cover. We need to do additional things. Now when you get done insulating and you put that cover on, you're not going to be able to see that junction box if you cover it up with insulation. So what we have are junction box flags. I made one up, but then I ordered some, and these are real nice, pretty red ones. Now there's a few different ways that you can install these. You don't want to install it so low that when you insulate that you cover up the actual flag, because this is going to be how an electrician locates this junction box. Now you can either come here and use a simple staple gun and staple it to the side of the ceiling joist, right like such, or if that's not possible, you could come right up here to this roof rafter and secure this just like this. Secure that up there. That way when the electrician, if you have any kind of issues with your electric, he's going to look in that attic, boom, right there's the junction box. He isn't going to have to go sifting through, ruining the nice job that you did with the insulation. Now another thing is going to be these depth gauges. A few things with these. I like to see these in a nice, arranged nicely in an attic. Think of yourself as an inspector. You're there to do the final inspection, and you pop your head up in the attic, and these are spaced evenly apart, really nice, and say your insulation is all on this line, 13 inches or whatnot. My guess is the inspector is going to see that nice, clean, level insulation job. He's probably going to give you less problems. Now if he starts seeing some of them being down around the 9-inch, the 17-inch, maybe he's going to start asking some questions. But these will actually be nailed, if it's trussed, it'll be nailed to the side of the truss or stapled, but you want these stapled right here. This is actually going to show the depth. One thing that I've ran into, and I hope some of you folks aren't doing this, because you'll get in a lot of trouble if you do, and it really looks bad on you by trying to cut corners, but I've actually seen people cut these. And it makes it look like there's more insulation in that attic than what there is. Don't be a cheater. Do your job the way that you're supposed to do it. Use these. The less problems, the less obvious things that you're going to have your QCI inspector see, the easier your job's going to go through. You start boogering up things and chintzying it up, and I'm going to guess that you're going to have some problems. Now, we have to address something else up in this attic, and it's called these water lines right here. I have some water line insulation pipe. It's got a slit right down the top of it. You'll want to insulate these. This is pretty simple stuff right here. I'm not going to insulate all of them because, like I say, this is the prop house and it's just for demonstration purposes. But this simply just lays right on here. May want to put some zip ties or something to tighten that up. But any kind of water lines that you have, I don't know what kind of situation you're going to run into. Joe, the homeowner, has a tendency to fix things the way they want to fix it. And that's what you're running into when you're up in these attics. You know, it's not the perfect world. It's somebody that says, oh yeah, that's fine, I did it myself, until you get up in that attic and see what all they did. Because, you know, if it's out of sight, it's out of mind. Reinstall the ductwork up here. I'm not going to reinstall it because I'm going to make that into another video to where we actually show duct sealing. But basically, this is what you're going to do. We're going to go do a section of air sealing over in the Kneewall attic. It's a little bit cleaner. Maybe you can get in there and see how I do it. But that's attic prep. Okay, we're going to check for some air leakage up in the attic. And we're going to do a little bit of air sealing for this particular session because that's what this is about, prepping the attic. We're going to use our blower door because I can't stress it enough how important it is. And we're going to use a smoke pen. We're actually going to go up into the attic and look for some leaky spots by using this smoke pen and the blower door because these are the tools you folks have out on the job at hand to use, and I don't understand why you don't use them because it's going to make your life a whole lot easier. So let's actually go through setting up the blower door. Actually have the blower door in the door. It's been in here in the prop house for a while. We've been making some videos and such. So let me put my cover on because we got to get a baseline. How this is done, you want to turn your manometer on. Always like to turn the light on so I could see everything. Now mind you, we still have a duct unhooked upstairs, so we're going to see what kind of numbers we get off of this blower door. So we got the manometer turned on. We got to get it in the right mode. So we're going to press mode till we see pressure flow at 50 right here on the bottom. Well, now I put my cover back on my blower door because I got to get a baseline. So I'm going to hit baseline. It will not start clock counting down until you hit start. Now in a real life situation, you'd probably want this to count up to roughly 30. But seeing as we're in the prop house, I'm probably going to shut her off about 10, but you got to hit enter. So now we have blower door, pressure flow at 50, the baseline is adjusted. I'm going to try with an open fan shroud. Now my fan shroud is open, and you can see it's open. I've got everything that I need. I'm going to start bringing this to pressure flow 50 Pascal. Prop house runs about 2650, somewhere around in there. So that duct being disconnected up top does make a little bit of a difference. So now let's go upstairs with our smoke pencil in the attic and see if we can find any leaking spots.
Okay.
Now we're up into the attic. I'm going to light my smoke stick here. This is Jim Hall's pink lighter. So I'm using Jim Hall's pink lighter to light this smoke stick. So we'll see how this works. The smoke stick really ain't burning the greatest.
Should we blow it out to make the smoke? Oh yeah.
Yeah. So now I got some smoke going on. It's really not going anywhere.
Yeah, some.
It's trying to pull it down into these wall cavities. Let's look in this knee wall here.
A lot of this is so interconnected that there's.
Yeah, we got some smoke moving around now. It's coming out of this hat vent, so we got air leakage coming from inside the building. Let's check over here in this other attic portion.
Stick it in that open duct if you can reach in there. Well, you got your board going already.
Yeah, man, we got some air being pulled around here. It's probably being pulled right through that duct. But I wanted to do this smoke pin. This prop house has been dense packed on all exterior walls and things are pretty well sealed in here. But I'm curious about this portion right here. You see that smoke being pulled right in there? Probably a little bit of air leakage going on right in this particular cavity, and these are the spots that you can't find, that you're crawling around into the attic trying to see. And I wanted to do this demonstration to show how these two simple tools can help you find air leakage spots in your attic. GH had a great idea. We're down here in the living space of the prop house, and on last week's thing we showed receptacles, how they needed to be insulated, receptacles and wall switches. I still have this smoke pin going. We still have the blower door going on. I don't know if you can see it real well, but the smoke is going right into that receptacle or that switch. And that's a sure sign of an air leakage spot.
Most likely the partition wall's open at the top, like your balloon framing.
Yep.
So.
And it is literally sucking it right in there.
Simple solution, seal the top up. The way I show you in the other video.
Now we're going to talk a little bit about air sealing. We did some prep work in the attic with the can light, the junction boxes, installed baffle venting, but along all your exterior walls on a balloon frame home, this is just a demonstration right here, but it's identical. You're going to be doing the exact same thing.
And interior.
And interior, because if you're going to insulate your attic, you don't want a bunch of insulation falling down into your wall cavity, so you're going to have to put something in there. For today's scenario, we're going to use Luan. I cut this out of a piece of Luan that's sitting back here, but that's something that you could do with a pretty sharp razor knife. You can use fiberglass insulation. You can roll it all up and stuff it down in there, but it's got to be extremely tight. All it has to do is support the weight of the insulation on top. Now
It's also got to stop any air movement, so it's got to be sealed.
Yep, it has to stop any air movement coming up, and so it's got to be sealed, which we're going to do that very same thing. Now, if it's in a dense pack, if it's on an exterior wall, it has to be extremely tight because it's got to handle the pressure of a dense pack. But the process is identical. So I've already taken the liberty of cutting this instead of you guys painfully watching me cut this out of a piece of Luan. I already measured my cavity depth or size, and I'm just simply going to drop this down in place. And in proper Dave fashion, it fits tight, because that's the way we like it. And your Luan's in there. But now, like GH said, we have to seal it. I'm actually using silicone caulking. Spray foam works well, but unfortunately that's not necessarily what I'm dealing with. So I'm using
You got a puncture it too.
silicone caulking. And you gotta look out for the explosion. But we're gonna back caulk all this. We're gonna put a nice liberal bit of caulking on here, seal this all up, and stop any kind of air movement that is coming from this wall cavity right here. Don't have to be beautiful. You may want to wear some gloves, because this is going to get messy. But you want to get a good thorough seal all the way around. Clean off the tip of your gun in the hole. And if I can see the camera, we have sealed this particular wall cavity. Now we should be able to run blow insulation right over top of this. None should get down into the wall cavity, and it's completely sealed all the way around. Okay, let's talk about a little bit about drywall repair. You're probably going to have to do some drywall repair in order to be able to dense pack your walls and sometimes often to be able to insulate your attic. If you got holes in your drywall and it won't support the dense pack, or it won't allow you to be able to successfully install insulation in your attic, you're going to have to do some repair. So I got a couple different techniques that we can do. This is a larger hole. What it is, I know it looks pretty, like a really nice hole, but I trimmed it all out and such. And I've cut another piece of drywall that will fit in this particular hole. Okay, and here's how you're going to do this. I've got a scrap piece of wood that I've cut particular for this install. You're going to run it in here from side to side, and you're going to install. You're going to secure it with drywall screws. You just want the head of your screws just to dimple the drywall.
Could have room. Barely.
Okay. And now we want to secure our patch. And this is how we're going to do this. Make her squeal. Okay, we now have our drywall patch in. but we still need to finish it out. And I like this vinyl tape or this fiberglass tape because it sticks. Stick it on there, slice it.
We're doing pre-cut.
Stick that on there.
How'd you do that?
A lot of times we'll have to find the end. Fortunately, that wasn't too terrible. You always want to fold the end over on your tape so you can find the end the next time you want to use it. Trim off all your little boogers, press that tape down, and this is the fun part. You got your mud. Always like using a 6-inch trowel. You don't have to use the whole width because it's going to mash out. Come clear back here and get you a good bead across there. Don't be afraid if you see that hump. And you see me, I get the drywall on there, mud like that, and come right out here and fan that out. Same with your sides. It's going to look a little rough at first, but you want to really get that first base coat down. Now,
See, mine's got, mine popped up before too, so, this one.
if you could please mute yourself,
It's got 30.
Cherie, that would be fantastic.
Down 3 times. I've had that.
Hey, Cherie,
What's the other one that's supposed to be tonight?
It's zero. You two.
But I've got,
No, there's not even.
Cherie, will you please mute yourself?
It tells me what the information I need.
I never seen that.
After you get a base coat on like this, you don't want to get a whole bunch on because it's going to crack as it dries. You want to get this much on. You want to wait until this dries. I'm going to say this, a lot of folks are going to tell me that I'm wrong, but when you come back to this, the only thing you want to sand are these light high ridges. You just want to knock off the high points because you don't want to sand anything off because you're just going to have to put it back on. When you get done, your drywall patch is probably going to be more like this. So you can blend all this in. But that right there is a basis on how to do your drywall patch. Remember the other day when I was checking to see how deep the wall cavity was, I made this hole in here, and I did it for a reason. Inside the closet, you know, in an undisclosed location outside of the everyday eyesight, you know. But I really like this patch. I call this a cold patch. This is another way of patching a particular hole. If you notice, this is basically a piece of drywall. Just a regular piece of drywall. I had made a 2-inch square, and I've made it an inch bigger on all sides and cut out the big square from one piece of drywall. And then I came on the inside and cut it in and peeled this drywall off all the way around. So basically this is just a big square drywall with this piece missing, this piece missing, this piece missing, and this piece missing. Now, I've cut this the same size as the hole that I made in the wall. And this should fit in there just like this. That's going to be your patch right here. So what I'm going to do, got some drywall mud right here. You want to really be like using the regular old school tape, because you got to give that paper something to stick to. I like getting a little bit on the inside, make that patch stick, and I like coating. It's not really going to matter much if you get some of that cellulose on there, because it's going to take more than one coat. And you simply take your patch,
Yeah,
press
it's a
it in.
Zoom meeting, but see, it says
And then with your drywall mud,
text Tracy. No.
you want to mud over top of it. You want to push it down,
Oh my gosh.
but
So
you don't want to
anyways,
push it so much that you lose all your adhesive from your drywall mud underneath your tape. Therefore, you want to pull off as much as possible and then get a good skim coat over top of it. Let this dry, come back, and like I said about the other repair, when you hit this with a piece of sandpaper or whatnot, sanding sponge, you just want to knock off these high ridges. Just brush them off, because you're going to come along with another coat and coat that. The biggest problem a lot of folks do with drywall is they sand their first coat clear down to the paper, and then they put more drywall mud on it. And it makes no sense to me. Why are you sanding it off when you're just going to put it right back on? You need that base coat as a filler, because this repair might come clear out into here just to be able to make that wall blend. And if you're not real good at it, it's best to do this in a closet.
All right, that's all that I had for this particular session. Like I say, it takes quite a bit of time. There are a few times we made mistakes, or I made mistakes and had to go back to it. But there was some mistakes in what I did watching it, and like the caulking gun thing. But yeah, I hope you all got a little bit of information out of that. I hope it helped. Still more hands-on videos to come. Like I say, we're trying to do this as a process. We're going to show you how to insulate an attic next time, do a dense